and I wanted to just go over the confidence intervals and what confidence intervals are. So confidence intervals are basically like what I said, is you're taking the 68, the 95, and the 99, you're taking those percentages of the distribution of the probability, and you're going to report them when you do a descriptive summary. When you take a sample and you calculate the mean, you're doing a point estimate. So the mean is a point estimate. It's 1 point that you're giving, and that's your estimate. When you do the confidence interval, it's a range estimate. So you're giving a range of values as your estimate of the population. So you can give a range of what values the mean could take on if you were to have an experiment that was similar and gave you this same distribution. So the confidence interval is basically a range estimator. And so there's 3 parts that determine how wide or how close the range of the confidence interval is. And the 3 things are the sample size, population variability, and the percent of the confidence that you want to give, or the range of data that you want to cover from that distribution. That's what you call the confidence. How much of the distribution are you going to show in your range? Okay, so you've got a distribution, you've got a mean and standard deviation, you'll have a range. The confidence interval is a formula similar to that, and then what you use is you use a value from the table that represents what percentage of the distribution that you want to use. So for the normal, if you want to show 95%, the range that has 95% of your measurements in it, what you're going to do is you're going to take your mean, which is the middle, and then you're going to subtract and add to get the range, to get the outside range numbers. You're going to add the 5% normal probability number, or what is called the critical value. The critical value is the number in a standard normal that will give you a 5% cutoff of probability. If you do a 2-sided confidence interval, then you're going to have 2.5% on one side and 2.5% probability on the other. So you look in the table and you find what are the actual numbers for that, the actual z values. And so then you get the z values, and you take plus or minus z and then times, and then you're going to take the sample standard deviation and then divide that by the square root of n minus 1. So when you divide it by n minus 1 and you multiply it times that constant, and you subtract that and you add it to the mean, then you have 2 numbers that are a range. So I'm going to give the formula in the presentation, and you can see what the formula is. But it's basically your point estimator plus or minus some constant from the table times the standard error. And the standard error is the sample standard deviation divided by the square root of n minus 1. And there are other types of confidence intervals that you can calculate. That's not the only type of confidence interval that you calculate, but that's the most used one. That formula is the most used confidence interval that I'm giving you. And so you can use that in most general cases. When you get to categorical analysis, then we have to do it a slightly different way, because categorical analysis, you have to transform things. And so in categorical analysis, if you realize the confidence interval that we have there is the same on both sides, you add and subtract the same amount. So that's symmetric. But when you get to the categorical, then it becomes non-symmetric, and one side is larger than the other side because the distribution you're using is not symmetric. But we'll cover that, that's in another class. But I'm just giving you that's how you're either going to give your estimate as a confidence interval, or you're going to give it as a p-value. But usually if you're doing a descriptive paper, you'll have to give confidence intervals for the different measurements that you make and that you have to report. And that's how you'll do a confidence interval.